Hey everyone, this is Rohit, and today's video we are going to implement the first order RC filter that is known as a low pass filter. So the significance of this video to make familiar with how to implement the drivers for the RC filter and how to add with your code. So before starting the video, we will just go to the basics of the RC filter, and further we will look at using we will make a driver library for the RC filter, and we will implement with the Code Compose Studio for the microcontrollers. So the RC filter is nothing. It is a simple R and C and the transfer functions for the RC filter will be 1 over 1 plus RCS. So this is the first order low pass filter, and that helps us to remove the unwanted noise from the signals receiving from the analog to digital converter. So if we are implementing this RC filter in the digital domain, what we can do, we have to discretize these equations. So discretize of this equation, you can use the bilinear transformations. You can discretize the equations. So by using the bilinear transformations, the output will be equals to b naught into x of n plus b1 x of n minus 1 minus a1 into y of n minus 1. So this is the digital implementations of the RC filter, where b0, b1 and a1 are T divided by T plus 2 RC, and that is the B naught. B1 is equals to T over T plus 2 RC, and A1 is equals to T minus 2 RC divided by T plus 2 RC. So these are the coefficients of the RC filter. So now we are going to implement using the Code Compose Studio, and we are going to make the driver library, and this driver library is valid for any kind of the microcontroller which you are using. So let's follow the Code Compose Studio. So we came here on the Code Compose Studio, where the digital RC filter equations is b0 into x of n plus b1 into x of n minus 1 minus a1 into y of n minus 1. So for the driver library, we have to go to the low pass filter, or in which files you want to create the folder. So I just want to create the file.h file header file in the programs. So I'll right click on this one, go to new, and go to the source, go to the header file. In the header file, I'll just type the RC filter .h, and it will create the RC filter .h files. Now we have to add the h include stdio.h, and we have to include the f28 x underscore project.h library. So now we are creating the structure. So to create the structure, we are using the type def struct, and we are making the variables in the structures. So that is the float, 32 bits, 32, and this is the B0, and that is the B1, that is the A1, then the T, the sampling time, this is the R, resistor value, and this is the C, capacitor value, and we are giving it the name, that is the RC filter. So now we have to initialize the RC filter. So we are using static inline void RC filter init, and the argument which we are passing to this one is the structure. So here it will be float denominator will be equals to we are making the T plus 2 RC. So it is T plus 2 R and C. So this is the denominator, and now we are calculating the coefficients, that is B0, B1 and B2. So we are calculating the B0 will be equals to T divided by denominator, and B1 that will be equals to, so it will be V T divided by denominator, and A1 equals to okay. So this is the initializations of the RC filter. Now we have to write a main function. So the main functions which we are writing, that is the static inline, that float, then RC filter, and which we are passing the arguments, that is input, previous output, previous input, and we are passing the RC filter, so it will return the V0 into input plus B1 into previous input minus A1 into previous output. So it will return the values, that is the b0 input into b1 into previous input minus a1 into previous output. So this is the header files for the RC filters. So now we will call the header file into the main functions, and so here we are calling the hash include rcfilter.h, and we are initializing the RC filter as a low pass filter, and some values we are initializing for the cutoff frequency of approximate 1.3 kilohertz with a sampling time of 10 kilohertz sampling time, and we are initializing the b0, b1 and a1 as zeros. So now we will call this in our functions, and we will see what happens. So here as you can see that this is the RC filter, and we have given the inputs, that is the voltage read, and that is reading from the ADC, and we are adding some noise and noise amplitude. We are adding some noise with the random noise functions that we have discussed in the last videos, at the exponential moving average filter video. So, and this is the previous voltage, previous input, and we are passing the low pass filter. So low pass filter is, this is the structure, and we are giving the initializing the values here. So, and this is the main functions, and now we are initializing the low pass filter. So to initialize the low pass filter, we have to call the functions. So we have called the RC filter here, and we are passing the we are calling the RC filters, and we are passing the arguments. These are the arguments with a cutoff frequency of the 1.3 1.4 kilohertz approximately. So it will calculate the coefficient, that is b0, b1 and a1, and further after calculating the coefficients, we are calling the function, that is the RC filter. So this is the RC filter, and this will returning the float value. So this will be the voltage read, and we are adding some noise in this one, the previous voltage, previous input, and the low pass filter. So now what we will do, we will run it, and we will see the output. So there is no error. Now we will debug it. So now we will resume it, and we will see the response. So this is where we haven't applied any noise. The noise amplitude is 0, so it will be working as a fine. Now what we will do, we will increase the noise amplitude to 0.1, and you can see that the noise level. Now what we will do, we will further increase the noise at a 0.5, and you can see the input signal is having the lot of noise, whereas the output is having the less noise. Now what if we further increase the noise? So now you can see that if you are further increasing the noise level, it attenuates the noise level, as you can see in the graphs. So this is the way we can implement the digital filters using any kind of the microcontrollers, and it will help us to attenuate the noise. Now further, if you are increasing the noise levels, you can see that there is a lot of noise, still the shape is also getting regained. So I hope you understood the RC filter implementation and how to create the library for this one, and how to call the library in the main functions. If you like this video, you can share this video with your colleagues, and don't forget to like, share and subscribe and support my channel. Thank you. Have a good day.